Okay, this is the lesson on epidemiology that you need for the quiz on Monday. And the Duke tip of the day, if you don't take notes on this lesson, you shall surely miss some questions. Mm-hmm. Mm-hmm. Okay, outbreak, definition of outbreak here. Yeah, outbreak and epidemic are used almost the same, synonymous. Outbreak is when a disease is more than normal levels. So you'd expect there to be the flu, but if there's more cases than would be expected, then that would be an outbreak. An epidemic is usually used to as a little bit stronger term than outbreak. When you have a pandemic, is when it's gone worldwide. So you could say that when the first cases were reported in the United States after having started in China, spread to Europe, it was most likely considered a pandemic, or at least the World Health Organization did. So, relationship between those three terms, the first two are basically the same. The last one is worldwide, and they're all used to describe uh, disease. It could not necessarily have to be infectious disease, but they're all used to describe that to some level. Okay, what is a pathogen? Pathogen is an organism which can cause disease. It doesn't have to be a living organism. A virus is not a living organism, but it can cause disease. So is a prion. Excuse me. But a prion is not a living organism either. A carrier is an individual with no signs of the disease, but they have the disease or the pathogen which can be spread. So, in the case of people that don't have any signs or symptoms but are carrying the coronavirus, they are considered a carrier. A cluster is a term to use in demographics when you're learning about different folks, but this is usually used geographically when you've got a closely grouped area of disease or other health related conditions. So, again, it doesn't have to be an infectious disease, it could be a cluster where there's a lot of cancer occurring in a certain place. And mortality rate is dividing the number of deaths by the population at risk. But what we hear as mortality rate is actually the true rate estimates of the risk of dying from the disease. So that means people that have the disease actually have the disease, infected by the disease, how many of those people die. That's what we're hearing about in the news. Okay, epidemiology. Let's take a look at what epidemiology is. It's considered the backbone of public health. It's with any kind of disease or condition affecting health, what is happening? So, is it cancer? Is it a virus? What is it? And where is it happening? So, we want to know geographically where in the world it's happening and to which groups, which populations, certain age groups, let's say. And what can be done about it? How can it be prevented? How can it be eliminated, eradicated? Is when you get rid of something completely, or just how do you control it from being worse than it could be? So we look at disease. There's two types of disease: infectious disease and non-infectious disease. So when we think of disease, most people think of infectious, but we have to remember there are non-infectious diseases as well. Bacterial, caused by a bacterium, and that is a living thing. Viral, caused by viruses, which is not a living thing. It's a particle encapsulated, usually a lipid membrane. They have different shapes, but it's usually an RNA material, sometimes DNA, that is inside the virus, the viral particle. Fungal is by a fungus. There are not as many fungal diseases out there, as numerous as bacterial and viral, but one of the main ones we think about is probably athlete's foot. Parasitic, probably the grossest one to think about. Those are things like worms, small bugs, things that are very small, microscopic, almost always, and they get into our system and they feed off of us, essentially. They benefit from us and cause us harm, or the organism they're in harm. Prion, that's the one that's probably going to be new for everybody. A prion is actually a protein that is irregularly shaped. There's something wrong with the shape of the protein. Proteins have like billions of shapes, And Prion Disease, there's a few of them we'll talk about. Actually, mad cow disease is one of them that's not on the slide later, which you may have heard about. But there's some other ones that we talked about in a minute. Non-infectious cardiovascular diseases. I believe you all know about these. Chronic respiratory disease, an example would be emphysema. Cancer, all types of cancer, and diabetes is also considered as one of the types of non-infectious disease. Here's another slide that just shows the same thing, just puts a few different pictures to it right here. But on non-infectious right here, I'm sorry, I'm covering up it's a couch potato. It's a potato on a chair watching TV. When people don't exercise, that is a risk factor for a lot of different non-infectious diseases particularly. And the one that I'm most concerned about right here is eating these big hamburgers. Toxic waste, getting too much sun or ultraviolet rays is shown as a major risk factor as well. Okay, these are some things. What you need to do for the quiz is you will need to write down just the diseases under the category of bacterial. You'll have questions that say you'll name a disease like tuberculosis. And you may have choices like, is it bacterial, fungal, viral, or parasitic. And you would need to know which one it is. So this is Lyme disease, named after Lyme, Connecticut, where it first happened. And this is one that, although it's not usually fatal, it's something that stays with the person for a long time. It really is tough on them. There's tetanus, which most people should have a tetanus shot to prevent from getting this. Tuberculosis, TB, which is a very serious, can be fatal disease that affects the respiratory system, highly contagious. Fortunately, there's not a lot of it around. Bacterial meningitis and strep throat, which you've all heard of. Some common viral diseases: common cold, flu, AIDS, chicken pox, hepatitis B, West Nile virus, which is transmitted by mosquitoes, which is a concern here, and HPV, human papillomavirus. These are some fungal diseases. Again, these are names that you'll probably never see again unless you're learning about one specifically. But have the list of these diseases written down to where if one of them is given to you, it might be, say, blastomycosis. That's a fungal disease and not a viral or bacterial or other type. Some common parasitic diseases: malaria, which is more of a problem in overseas areas like India. That's transmitted by a mosquito bite. There's several other ones on this list which you can read. Parasitic diseases, one that I would add but you don't have to write down, is Giardia. That's one that you could get around here, and typically ingesting water that's contaminated. Giardia is a little critter, a little parasite, and it'll cause you intestinal problems. You might have to run to the bathroom a lot. Okay, prion disease. Again, a prion is an irregularly shaped protein. Just know that part. That's what's important to know. It is communicable in some cases. In some cases, it might be genetically passed on. One of the most commonly known is called Jacob-Creutzfeldt disease. And what it does, most of these will affect the brain. And what it does is it eats away at the cells until the brain is like a sponge. And these are almost always fatal, all these prion diseases. Fatal insomnia. There's a case of a Chicago music teacher that got this. He could not sleep for 6 months. He was hospitalized and he died in the hospital after not being able to go to sleep for a period of 6 months. And it was a very difficult situation to diagnose. Oftentimes this is genetic, but very, very rare. Kuru, one you probably won't forget, and I'm sorry I'm covering up these native folks here. In Papua New Guinea, which is over in the Pacific, this is caught when people who are cannibalistic, they eat other people, but they eat the deceased. It's a ritual to where they do this, and it was discovered after they were sick with this unusual disease. When they learned about the people and what they did, this is how they got it. So again, it's limited to these folks who are cannibalistic. One reason not to turn cannibalistic. The CDC is the Centers for Disease Control and Prevention. The last part was tagged on there a couple decades ago. They're based out of Atlanta, and they are the federal agency charged with working with disease, not just infectious disease, but things that we saw on that list like cancer, diabetes, cardiovascular, and the ones that affect the lungs. So know that they're the ones that it seemed like on the news they were out there a lot more in the beginning, and you don't hear about the CDC as much, but they're still on the front line working or when it comes to a vaccine. They're the ones that are going to be monitoring that situation and figuring out what needs to be done. They also provide a lot of statistics. Okay, how a virus replicates and spreads. A virus is not living, it's not made of cells, so what it needs to do is it needs to attack a cell. Actually, there are plants that get viruses as well as animals. So the virus has these special receptors that trick the cell into letting it in. So the cell has a virus attached to it. It gains entry into the cell. And once it gets into the cell, it takes over with the enzymes and all of the different organelles, like you learned about the ribosomes that create a lot of that build particles for the cell, and they trick it into making more of itself, more virus particles. So in that assembly stage, all these viruses are built, and then finally, there's so many virus particles in the cell, it could be millions, hundreds of millions, and it will burst the cell and release, and then the virus spreads from there. So you can see how it can quickly spread when it infects one cell and is successful at hijacking that cell and making more copies of itself. How does soap work with the coronavirus and other viruses, but we're going to concentrate on the coronavirus. There's a lot of extra words on here that you don't need to worry about. What I want you to look at is this lipid membrane right here. When you use soap, it doesn't have to be antibacterial soap even. The soap will break apart or dissolve this lipid membrane, and the genetic material inside here, that is what the virus is carrying and spreading, will be destroyed. So soap can almost instantly neutralize the virus. I say not kill the virus because it's not a living thing. So it neutralizes the virus, makes it harmless, and that's why you hear so much about washing hands is important. So if you understand that and how it works, hopefully the washing hands part people will take more seriously. This is the math behind social distancing, a term that we probably never heard of 2 months ago. If one person has it and they're not practicing any social distancing, so imagine like when we were back at school, and if somebody would have had it at school, which they probably didn't, but if they would have, then in 5 days, they probably had infected 2.5 people. Imagine, bear with the math here, that you've got not a half a person, but mathematically speaking, that's how the statistics would play out. And after 30 days, those 2.5 people would infect 406 people. That's an exponential increase. The curve on that, it goes up. It's not linear. 50% less exposure, one person. So half the people you're normally come into contact with, an average person, after 5 days, they'd infect 1.25 people, 1 in a fourth persons. And after 30 days, 15 people infected. So you can see the difference between 50% social distancing and no social distancing, where 406 people are infected after 30 days and only 15 after 30 days. And that number goes down a lot with 75% less exposure. One person affects less than one person statistically. And then after 30 days, 2.5 people are infected. So that's why the math behind why social distancing has been the main preventative measure that the public has been taught, been educated in. Okay, what you need to know about this is you hear about flattening the curve. Flattening the curve means the number of new cases is reduced. You don't have an increase in new cases. So you can see in red right here where it shows China, after about, it looks like it was days they were looking at here, after about 30 days, there was a pretty noticeable flattening. It may have started at 25, so that means measures were taken that hadn't been taken before that were slowing down the spread. So flattening the curve is slowing down the number of new cases for any disease. In this case, we're tracking the coronavirus, COVID-14. That's the lesson. This is a couple pictures of the garden taken a week ago Monday. And the main difference here you can see is the coreopsis right here, which you should have labeled on your chart in OneNote, your garden layout. That bloomed big time. All the plants are doing well. Maybe one or two of them a little bit weaker, but out of 36 plus 3 jalapenos, we should have close to 40 new plants that will be growing. And I'll update it weekly and probably put a page in OneNote where you can go if you want to scroll and see the progress of the garden on a weekly basis. That's it. Ask questions, take notes. If you don't have the notes with you when you're taking the quiz, you'll probably will miss questions, I'm almost certain. But you can use your notes during the quiz. You'll have 20 questions and 30 minutes to answer those 20 questions. Also, I want to say if you're using Lockdown Browser, and this happens, it'll probably happen to somebody, that it locks up and gives you an error message. Just close the browser, exit out in the top right, and then you'll have to answer a question like that you want to leave. You just type anything in the little box and hit close browser, continue to close browser. Go through that process, then just reopen it again with a password, and it will save your progress. From the last time you changed pages, you won't lose any of your answers. So I want to put that out there now, and I'll probably remind you again of that before the quiz. Aloha.